Okay, so let's talk about rational numbers. Specifically, we're going to talk about converting between fractions and decimals today. So in our TOC, slide this mouse out of the way. In our TOC, we're going to put Unit 1, and we're going to put converting between fractions and decimals. And we're going to start that on page 2. And it may take more than one page, but we're going to start on page 2, and we'll come back and update how many pages it is after we take the notes. So let's go ahead and go to page 2 in our paper math interactive notebook. Page 1, if you remember, we still have our notes on the real number system. So page 2. Let's talk about repeating decimals at first, because our focus is going to be on converting between decimals back to fractions, specifically what happens when we're dealing with non-terminal decimals. So what does it mean to be a repeating decimal? And sometimes we call that reoccurring or recurring. Okay, so a recurring decimal is a number whose decimal representation becomes periodic. And when something is periodic, it means that it occurs over and over or at specific intervals. So meaning the same digit or sequence of digits repeats infinitely, meaning that it never ends. So that is what a repeating decimal is. And within repeating decimals, which by the way, all repeating decimals are part of the rational number family. And I say that because there's some type of digits that repeat. When we look at irrational numbers, those decimals will never end, but there'll be no sequence of repeating of the decimals. So repeating decimals are considered rational. So the first type of repeating decimal we're going to look at is terminating. And that's when the decimal digit that repeats is 0. Okay. Meaning because 0 does not impact the value of the number. So for example, if we have 0.8700, if we change that to a fraction, that would be 87 over 10,000, or actually 8,700 over 10,000. And if we were going to simplify this, the zeros would cross out, leaving just 87 over 100. So if we eliminate those decimals, we just make it 0.87, we still get the same answer as a fraction. Okay. Whereas non-terminating decimals, which is the second part of repeating, occur when the decimal digit or sequence of digits keeps repeating infinitely in the same pattern. Examples would be 0.333 when it keeps on going. We just mark that as 0.3, and then we use something called a bar notation. Okay, so bar notation, I realize I didn't put much of a space there, but it's bar and then the second word is notation, is the symbol for signifying repeating digits after a decimal. So when we see that, we know that that digit or digits repeats infinitely. And we call that part of the decimal the repetend or the reptend. So it's the digits or digits repeating after a decimal marked with bar notation. So the questions we want to ask ourselves a lot of times is we want to figure out when we're looking at a decimal, what are the significant digits? So significant digit or digits are digits, meaning numbers, that contribute to the value or accuracy of the number. So some examples of that, 0.200, these would be insignificant digits because I can represent this fraction as just simply 0.2. Because if I wrote it as 200 thousandths, those zeros would cancel out, leaving me with 2 over 10, which could represent itself as 0.2. Something like 200.202, I can't just get rid of that zero. It contributes to the value of the number. So if I had 202 1,000ths, that would not simply be simplified to 22 hundredths, right? I would have to simplify based on the entire number. Also, putting a zero in front of a decimal, that's insignificant. right? So all of these are significant. Here, the last two, those zeros at the end, they're not significant, and zeros in front of the decimal where there's not another digit in front of it. So if this was 80.2, of course that zero would be significant, but zero by itself does not represent a value. Of course, then insignificant digits would just be that, what we pointed out, digits that don't contribute to the value of a number. So that's kind of like some of the language or vocabulary that we need to have for this next section. So we're going to move on and do a second video, and I'm going to go through the steps on how to convert fractions to decimals and terminating decimals into fractions.